which probably it would be repetitive, and it would be a bit of same thing maybe. Before I start into questions and session, we have I think roughly 1 hour, right? 45 minutes. Okay, so it's much shorter. This session generally takes 1 hour 45 minutes, so I have less time, but I'll try to cover whatever I could. Uh, and I'm really happy to see a huge turnout. And I've done some meetups and other stuff, but I've never seen so many people. It's so great that ThoughtWorks have such a huge community. It's so great. Uh, Again, like we have a tradition at Elastic to take a selfie with all the people in the in the meetup or something. So and we post it internally in the Slack channel. So I'll just I mean just say hi or lift your hand or something. I just want to take a pic with everyone. Okay, so we'll definitely have a much larger pic, definitely. Uh, so coming to the session, I don't know. Like I thought, like I'll just ask everyone. Generally, I just ask every user or person, and then I'll check. Okay, this is what they were looking at, and then I'll tune my content into it that way in meetups, not at conferences in meetup. But how many of you use Elasticsearch? Because there are so many people. Use in the production, or how many of you don't? I mean, like no Elasticsearch because there are less hands. I just thought or heard of the keyword Elasticsearch. Okay, Elasticsearch probably everyone would have heard. So what I'll do is like, see, if I start telling the entire story, it would be really difficult. So I'll play a 3 minute small video from our CEO, and then you would only see some text and stuff. But it would be probably like interesting for several of you to learn and see where Elastic is used and a lot of stuff. So let me do that before I start really from half of the presentation. And because there is no mic, I'll just put the same one. Okay. Let's try. This works. You're able to see this, right? Yes.
We will always be searching for something. Why we search remains constant. We're looking for insight, information, and answers. But how and what we search changes over time. From the Dewey Decimal System for libraries, to Google for the World Wide Web, to conversations with virtual assistants for everyday inquiries. Today, what we search has grown to include a rapidly increasing amount of structured and unstructured data, from a multitude of sources such as databases, websites, applications, and mobile and connected devices. It's natural to think of search as just a box where you type in some text and results appear. But search is more than that. It's about dragging your finger across a map on your smartphone and watching it redraw itself as it shows new locations. It's about selecting filters to group what you might have for lunch into specific categories, or visualizing billions of log messages in a histogram to analyze errors. It's about forecasting data center storage capacity 2 weeks into the future with machine learning jobs, or monitoring application performance as a customer goes from add to cart to order confirmed on a retail website, or even analyzing user sentiment with natural language processing. All of this is search. Elastic is a search company that makes it easy to build search experiences that power the use cases and applications of today and tomorrow. You may not realize it, but you probably use Elastic every day. When you hail a ride home with Uber, Elastic is what pairs you with a nearby driver. When you search for groceries on Instacart, Elastic is what provides relevant results and recommendations. When you swipe left or right on Tinder, Elastic is what matches you with people you might like and who might like you back. At Cisco, it's Elastic aggregating pricing, quote, and configuration data to complete every order on their commerce platform. At sprint, Elastic is what processes billions of log events a day to monitor website performance and network outages. And at Indiana University, Elastic is powering cybersecurity operations to protect thousands of devices and critical data. Elastic is the foundational technology solving mission-critical problems for more than 5,500 customers. And as they grow, we grow with them. In that sense, we believe that our company is truly elastic.
So yeah, that's it. That's what we do. Like that's what where Elastic is used today. So I'll start from the middle. So I do also have whenever I start sharing about all of these details, I'll start from that particular point. But today we have anyway less time, so I'll start from the technical or much lesser use case related more technical than use case. Okay. I hope you guys have probably understood that what we do or like what sort of experiences that you could build with Elasticsearch. Elasticsearch is a search engine, and when search is a constant foundation for a lot of apps or a lot of things that you generally do. But apart from search, every data problem or majority of data problems today are search problems. So that is why you would be able to build analytical engine or something like something that would do aggregations or something that could do many things like even machine learning or everything, because everything is powered by a search problem or everything has a search problem. So what we do is today is like we'll start covering this particular thing, Elasticsearch, and we'll see if we get more time, we'll cover the other modules as well. So Elasticsearch is one part of the entire stack, what we call as Elastic Stack. There are other parts like probably you might very well know, right? ELK, Logstash and Kibana, which is another modules. There is something called Beats, if you have heard of. Beats is a platform again written in Go. Everything is open source. All of the stack is open source. You could do multiple things with all of these details. Today we will try to cover the heart and soul of this stack called Elastic Stack. We will also look into the UI, which is called Kibana, through which we will talk to Elasticsearch. And Logstash and Beats are kind of ingestion modules wherein you would be able to pull data from various sources or push data from various places. If time permits as well, I will show you that sort of a demo wherein you will be able to learn more. So I'm expecting that many of you are not really into Elasticsearch, probably using one or the other use case. I also expect that we will try to recover or rebase this entire learning experience that you already have. Probably you might be knowing some sort of keywords, terms in Elasticsearch, and we will see how it goes. And then and when if you think it's so basic, we will skip that particular part. So agree with me, right? So many are okay to cover the starting part of it, because I do cover some extra stuff, advanced stuff that you would definitely like, because as the previous sessions, I could see that you were learning about Envoy, Kubernetes, control plane, data plane, which are like kind of advanced topics maybe per se, but you could see Elasticsearch, we will try to look into from a different perspective. So I'm thinking that it is okay to cover some sort of basics, right? Agreed? Show of hands? Okay, not many maybe. You are looking at some advanced stuff? You just need to talk, guys. I don't want to do monologues. So I always want to connect to my audience and I always want to talk to people. So I just want you to raise hands and I'm probably stop me in between, completely fine. So we will do it that way. Even though we spend 30 minutes, you will be able to learn something. Otherwise, it's a waste of time for both of us. Like it's much better. So first of all, like I don't know, like how I don't know, but it is not so well. I'll just change my orientation or something, and let's see. So I don't know how many of you again know this particular the terms and keywords that we generally use, or why the names, or why it was called in a particular fashion. Yeah, so I'll just reduce it much smaller. Okay, so we will cover the terms part of it first of all. to see that what exactly Elasticsearch and what are the key terms that we generally use. So whenever we talk about Elasticsearch, it's a distributed system and it contains something called cluster and node. So cluster is a group of nodes, and nodes are machines which run Elasticsearch. Suppose if you are in a machine, and if you have a node and then you are running multiple Elasticsearch processes, then each process becomes an Elasticsearch node. That means if you are running one process, that becomes a node for me. If you are running 10 processes, probably it is 10 nodes for me. But wherever you are running, like if it's a machine where you are running a Kubernetes cluster and then you are running containers on top of it, then each container is running one Elasticsearch process, that becomes a node for me. So I'm just trying to put it in that way so that you will be able to understand from that point of view. So we covered cluster and node. Then another thing that you might know or you might not understand very well, like how about why do we think that? Okay, anyway, let me cover that. So index is your logical space to store all your data in Elasticsearch. So whenever you talk to Elasticsearch, it's always an index that you talk to. So you don't talk to anything like a table. So your index name or index is your table for your Elasticsearch, and it contains all the documents, everything. So why do you think that we kept a name as an index?
Maybe we should map to the labels of the data to the point.
If you open a book and you want to find something, you go to
Yeah. So it's very clear. I mean, exact abstract explanation of how you do. Technically, we might think that index is a key value pair or index caches something, but actually the reason behind why index has come is because like it's like kind of something that you want to look it up, right? Elasticsearch is a search engine. It does full text search analysis. We'll look into that angle as well. But basically, when you want to do structured or unstructured querying, your index plays a role of your, the single point of contact to ask any questions. So that is a primary idea. We used to have something called types, which are deprecated. So you don't need to worry about it. But if you are running a lesser or probably a older version of Elasticsearch much before 6.0, or you have upgraded your infrastructure, I would like to throw some data or information about it. So Elasticsearch is a search engine. It's not a database. It can be used like a NoSQL data store, but it is not your single source of truth, because you don't, or you might not be using that as your what you call, you don't use something like a DR or a disaster recovery for Elasticsearch. I do see a lot many people don't use it that way, but it is recommended when you are using as a single source of truth like a database, because database does what they take backups of database, they use that as a disaster recovery strategy and then go forward. But with this particular thing, if you are not looking at, if you are not taking snapshots of your cluster, if you are not really concerned, or you don't have a plan of failure, everything, if you don't have, and you're using this as a single source of truth, we really don't recommend using Elastic like that way. So definitely you could use it for like a data store or any of these use cases, but the point is like make sure what you want to try, then also configure a disaster strategy as well. So that is much important. Elastic is not a SQL database. Ironically, we also have a SQL support. Like you could write SQL queries on Elasticsearch, and then you could ask questions and get data. That is definitely there. But we are not a SQL. So if you look at SQL DBs, right? SQL DBs have some properties called ACID properties, normalization. It also satisfies some theorem called CAP theorem. If you have heard of CAP theorem, it satisfies the consistency, all of these principles. Like so, Elasticsearch is a NoSQL data store. It doesn't come into that area as well. It is completely different. So, from the point of RDBMS systems, don't think and don't create probably like a how should I say? Like if you are trying to establish relations, well, don't try to think it of like index as a table and your documents as your rows, and don't try creating foreign key relations or like some sort of that you can't do anyway, but don't try to visualize like that. Make your data flat. So that comes to our point, next point, which is called document. So everything in index is a document. It is not a PDF or PPT or Word document. It is a JSON document. So we eat JSON, drink JSON, and sleep JSON. So it's all JSON for us in this company. So any product, everything is JSON. So most of the stuff when we define API, when we create API, we always use JSON as a REST body or a request body. So documents for us is like, for example, every log line is a document for us. Every row in a table is a document for us. All of these, every data point that you give to me or Elasticsearch is like a document for us. So if I say 1 million documents in an index, that means I have 1 million JSON documents. So every JSON document has some attributes, obviously. So you will also have some meta attributes. You will also have the real data. There are several things again when you talk about documents as well. So there are operations. All the operations, when you ask, these are the documents that you get as a result set in the return. You don't get rows or something like that. You get an output in the sort of JSON. And this is very important. I mean, how many of you have done this configuration or like asked questions or searched on Google? How many shards should I have? Right? There are quite a few hands. Good. So this is another common thing that people stumble upon when they use Elasticsearch. Like shard is your worker unit. So how, if I have to say, your index is your logical location, logical home for your data. Your shard is your physical container which hosts the data. So what we do is, generally, I'll show you a diagram far into the presentation, but to understand at this point of time, it's like if you have an index like a big cake and you put 4 or 5 containers on top of index, or okay, index as your logical plane, and you have 4 containers which is taking all your data parallelly. So if you have 1 GB of data, think of having like 250 MBs of shards that are configured, which is holding the real data physically on a disk. So your shards are tiny worker units that will work on your queries. Your index is just your logical reference point for talking to all of these shards. If you might have 20,000 shards or like 2 shards, whatever, you always talk to your index, you don't talk to your shards. So that is how it generally happens. Another interesting thing that you might not notice, like whenever you whenever you start asking questions to Elasticsearch, if suppose it's a distributed system, you have multiple nodes, then if one of the node crashes, then in this case it simply the data simply vanishes, because I said that I have 3 nodes, 3 shards, then a chunk of my data is sitting in the second node. Think of second node gets crashed. So what do you think that we should have been doing at this point of time, if you're following? So yeah, so this architecture, what it has is like, it also gives you a replica shard, a copy of the same shard which is there elsewhere in another node, not in the same node, running and active, and it also takes queries. So how it is defined is, your primary shards will take all the create, update, delete requests. Your replica shards will take your read requests. So your primaries will also work on read requests, but when there are more writes, and then when there are like a sizable number of reads, then your replicas will work on your reads. When I say read, it could be a query, regular query. When you are asking like underscore search, like search for a particular thing, then it goes to the particular shard or a replica shard. So that is one use case, parallelism. Second use case is fault tolerance, obviously. Like when you have second node crashing, then you need a backup for you to suffice this entire thing. Like somehow it should get copied, right? That's a replica shard plays the role of fault tolerance and making sure that things work properly. So a lot of people ask us about questions like, how many shards should I have in a cluster? Suppose if I have 10 GB of data coming in, like should I have 5 shards or like 10 shards? How do I size this entire thing so that my cluster is ready and everything working? So we have more than a couple of factors that we want you to consider. I'll also talk about that. Cluster sizing is another topic that could take definitely 45 minutes, because it involves multiple things to consider. So these are thought processes, because Elasticsearch is a building block. It's a platform where you could mold it in a way that you want. For some people it's a search engine, for some people it's a monitoring system, for some it's a security system. So each people or each person or each organization have their own data needs, their own scalability issues. Suppose for somebody like a Walmart, they have huge infrastructure. For somebody like probably a startup, they are just starting up, then they might have 2 node cluster and they might have very less CPU. So the servers are also less, so the data is also less, and the queries are also less, users are also less. So it depends on varied factors, coupled with the kind of use cases that you want to use, or kind of query throughput that you want to use. So we'll talk about that as well. So these are the terms that I probably use in the coming slides. So that's why I made sure that. So there are several types of nodes like in any other distributed system. I hope several of you might know Hadoop. Hadoop, yes, maybe. I just assume that you know Hadoop, like Hadoop has this master node, data node, all of this. Similarly, Elasticsearch has this master node, data node, there is a coordinated node. Each node has its own role and functionality. So if you don't define anything, you just go to bin Elasticsearch, it simply starts up. And every node becomes everything. Like in a startup, everyone wears all the hats. Like everyone becomes a CTO sometimes, architect sometimes, everyone starts doing everything. But as you grow, you might want to have teams, you might want to people to concentrate on a particular function, right? So similar way, if your cluster is scaling up and you have more things, you could definitely designate tasks and roles so that they would be able to perform in a much better manner. So here, if you have master node, which is used for administrative purposes, data node, which has data, but also master node contains a lot of data, which is kind of a meta nature and which is tightly linked to your data node. Coordinated node helps you in better routing. Like when you ask search queries, how does the search query get routed? Like where there is something called adaptive replica selection, automatic things where you ask a query, it automatically finds out a node or a shard which is having less, having less CPU or less loaded kind of things. So that can be done when you have coordinated node in place, which does that routing of requests. It's kind of a load balancer. Then you have ingest node. So we have introduced this in 6.0. What ingest node basically does is like we used to have Logstash. I hope majority of you might know Logstash. Like it is a ETL kind of a tool where you could pull data, transform data and stuff. So what ingest node does is it can do the same thing inside your Elasticsearch cluster. It can transform your data. So you could define the configuration, and suppose if it could be something like if you have an IP and you want to transform it into a longitude and latitude, like from where the IP is coming from, which geo in the globe. Is it from India? I mean, everything has a coordinate, right? Or it's a Bangalore or Chennai. So you could make all of those sort of transformations in data using the ingest node. Ingest node has pipelines. Again, this is the data pipeline. You could build these data pipelines. You could do all of this stuff, but it in a very smaller way, not so much. If you dedicate ingest node, that work only on that particular role. If you don't do it, every role can also perform ingest node, but you need to look at also look at like how my cluster is overloaded as well. So make sure that when you want to do it in that manner. So machine learning node obviously runs machine learning jobs. Yeah.
Ingest node does the transformation data at rest, or like again allows the dominant side.
Yeah, so when it is in real time, as the events process, I mean events come into the Elasticsearch, it gets processed. It's at that moment. So what powers Elasticsearch? What do you think that powers Elasticsearch? I think I gave the description, but I didn't tell the name. Yeah, great. So Lucene is the one that powers Elasticsearch. Lucene is a library. It's an Apache library. It's a full text library. How many of you have heard this name called duck cutting? Yeah. Who is duck cutting? Yeah, duck cutting is a Hadoop founder. So Shai and several of these information retrieval folks, what they used to do is like they work together. They used to work together, and then when because of a paper from Google, they started this project called Lucene, which does full text search analysis. Then later days, when GFS came, Doug moved on to a different project called Hadoop, and then Hadoop became a big thing actually. But Lucene is the thing, even still it is under development. Lucene, Elasticsearch contributes, or our company itself contributes to Lucene a lot. We sit in the project management chair and like we do a lot of things, releases, etc. But Lucene as a library is very complex to build or use. So Elasticsearch is not just a wrap around that jar. So we add several of these functionalities like speed, scale, relevance. If time permits, we'll talk about relevance, etc. But basically, Lucene is not just Lucene. You can download Lucene and then put in your Spring Boot app. Try to build a search experience. You'll be able to know that what sort of difficulty that you will face, because it is a wonderful developer product. But it's also complex to build a experience like that, a ready-made experience which is scalable, distributed, and all of this stuff. So Elasticsearch brings that like a package to you. Again, which it contains all of these APIs, etc. So how do you talk to Elasticsearch? Obviously APIs are there, so you could use something like curl or a postman, or we also have clients. I don't know how many of you use clients today. So how many of you are not DevOps and like probably are using clients or REST clients of us? Good. So we have REST clients for each of these libraries. These are wrappers around our APIs. So it's like, suppose if you are working in the space of Java, so you could simply say Elasticsearch, Elasticsearch is equal to new Elasticsearch, and say give the IP of Elasticsearch, and like things start working. Then you start creating the regular way of like getting a commons library and working like that. So similar way you have Elasticsearch clients for 7 or 8 languages. We support everything from like Ruby, Python, Java, JavaScript, .NET, Lua, even maybe Go in future. I mean, we also have Go, but it's not fully developed or actively developed. So obviously Logstash Beats. What Logstash Beats does is like Logstash, as you know, like it's kind of a extract, transform, and load, where you could connect to multiple plugins. Like you could pull data from databases, or GitHub kind of, or social media, or even Kafka kind of message queues, anything, literally anything. A lot. There are more than 300 plugins for Logstash itself. Then what Beats does is like Beats is a push platform. If you are in the DevOps or infrastructure domain where you want to do monitoring, etc., then you could use Beats platform. Beats contain, there are 8 beats I think at this point. Each beat does a specific functionality. Like for file beat does shipping of logs, audit beat for audit events, mostly for security like events, etc. Packet beat for networks, metric beat for metric collection, all of this. Each beat does a specific functionality. So I'm just moving on faster because we have very less time. So how do you index a document? It's pretty simple. Suppose if you have 3-node cluster, now this is where the shards, so the small containers are the shards. So whenever you ask a question or put a document, it can go into any one of this shard. Like it just happens. I'll also tell what powers this particular thing. So so if you see here, P0, P1, P2 are primary shards, and you R0, R1, R2 are replica shards. So whenever you are probably if your master or the main node goes down, then you already have a replica which is working. You will not see any difference, but you will get there is something called cluster state, which is like red, green, yellow. So that will change, and you will get a lot of alarms if you have configured. So there are the regular stuff like you can do document and you get more details. I'm sure that you'll not be able to see a lot of this, but basically it gives you a lot of index metadata. Important point to note here is if you give a ID to Elasticsearch API, it will consider that as an ID. If you don't give an ID, of course we generate a UUID, forget about it, but I'm talking about underscore ID. So if you give an ID, we will consider that. If you don't give it, we will generate one. If you give a logic to generate, we will do that as well. So it's all in your hands. How do you tune that? How do you create that? What do you want to do it? So many people think that you need to you think in a SQL manner. It's not wrong because we come from a SQL background. We were taught at colleges and all about SQL. So because of that, we try to think in a structured manner, but NoSQL or the databases or the data stores work a bit different. So there are APIs like bulk API, scroll API, where you could access the data normal way. Like if you want to push bulk data, you could use a bulk API through which what you could do multiple operations at single sort of time. Like you could probably do something like do either if it contains like 5 minutes or like 5 seconds or 1,000 documents, whichever is first, push the data. You could configure such intervals in your client or with this API, and then the data can automatically go. Many people think that bulk API is one-time use or like push the data at single shot of time, but no, you could configure such stuff so that when the buffer gets filled in your client, it can push the data. That is also another thing that you could try. So like I told, whenever you put this data into Elasticsearch, where will it go? So this is not something that to play with, not to change with. if you ever thought, so one of the prime things that people do is whenever they don't get cluster is not scaling up or cluster is not having enough data, then what they do is like they try to change the data to a particular set of nodes and try to make sure the data flows into that area only. So this is the algorithm, or this is the value where we get which shard to go, or where the document should go, or which shard number. Like if I have three shards, 0, 1, 2, 3, or 0, 1, 2, then the 0, 1, 2 gets decided here. So your ID, your routing value is your ID of your document. So we generate that and we push it. Obviously, we do some sort of balancing between the shards, like internally. We have something called cluster state. We do monitor some metrics. We automatically do that sort of a GC and everything. We do manage this cluster stability, etc. But if you are really looking at trying to push the data to a one particular node or some set of nodes, it's not recommended because it might really disturb the distributed nature of the product itself, because you're trying to put it in all the things at one place, then you don't get throughput again. So it's a waste of time. Another thing that why we don't want you to play with this thing as well is suppose if you change the routing ID to a custom ID and you change it and you put it in a specific place. Later, to retrieve the data from that particular shard, you need the same routing ID. This is like a key to pull the data. So if you forget the key, or if you are not able to generate the same key, somehow, some reason, if you don't have data, which generally happens with a lot of customers, your data gets lost. So when you are looking at this particular thing, I don't think you will be able to, you will look at it. But if you are reading something and trying out, please look at this sort of thing. And all the APIs are there at Elasticsearch to play it and disturb it in a way that you want. You can change even threads. You can change the heap spaces and internal GC config, everything. But just to know more details. So a larger part of this discussion, or what I want to basically use, is like how does this product itself works, or what is the thing that really scales this entire thing. So whenever people use Elasticsearch, they start just using it and things automatically work. But after a period of time, you start feeling that growth pain or things will not scale. So something of that sort would generally happen. So why? Because there are some caveats to be understood whenever you're looking at building a product or building a solution on top of Elasticsearch. One important thing is mappings and analysis. So forget about full text analysis like building a search UI or search experience, but basically if you are looking at any sort of regular search queries or regular thing, normally when you want to use Elastic, mapping is a basic thing that you need to look at. Unless or until, I mean, when you're looking at logs or as well, you need to look at that. So why it is important, I'll ask you a question, probably you might be able to tell. So what do you think the data type of count would be? Integer? Okay. String? Okay. Float or double? No, right? So Elasticsearch by default, when you put a document, you don't create this mapping, etc. It dynamically generates one mapping. Mapping is like your spec or your schema. Elasticsearch is schema free, not schema less. So it contains some schema. So it generates some schema. So the real data point or the data type that is automatically found, it's called long. So now you might think that what's wrong with it? Like int long means a bit more. I'm just I'm completely fine. But if you know that your value of your data type is not more than 32,000 or minus 32,000, you're just wasting an extra bit of space. We allocated more. So similarly, you could look at cases like, suppose if you have a number which you want it to be considered like a keyword, but then you might be I hope that you might know data types. Look, Elasticsearch data types, what it does is like keyword is something that is very special and it's like fastly searched through. So if the number is considered as a string, so string contains or string is indexed or put into an internal data structure in a specific format in Elasticsearch. So when you search for that particular value or attribute, it won't result you good result. Like it will be slow and you will see a lot of problems over a period of time. Not immediately, but over a period of time we might face that. So for example, let us take a use case of FedEx. What is so important at FedEx? What do you think? What is that particular thing that's so important to search through at FedEx kind of a company? Tracking number. So if I am putting this tracking, so I'm trying to build a search functionality. When people search for this thing, I want to show all the details where the package has been to in a place, right? So I want to build a search function through which I will be able to get details. So if then the tracking number sometimes could be alphanumeric, sometimes could be a string literal, sometimes could be only number, right? So if you think that I don't do this sort of mapping and I just put the number, and think that Elasticsearch somehow considered it as string or a different data type that it assumed. So what happens is like the throughput would be very less. By default, it considers it as number or some sort of an integer data type, right? But actually, you want it to be like a indexed or cached value where you will be able to search through it and you would get results much faster. So there is a data type called keyword. Suppose if I want all the my searches are mostly on users, right? User names. Then my search should be based on like if I type user name, I should be able to get results in like probably 3 milliseconds. That is my use case. Then I want to index that particular attribute in a keyword data type. Then it'd be much faster. So mappings play a very important role. Elasticsearch, whenever data comes in, it does some sort of optimization and indexes it at that point itself. So that is how you are able to get more and more fastness or throughput. That is how you are able to get a different sort of experience. Otherwise, it doesn't really, whenever you ask search queries, it doesn't go and work and generate data at that point. So this is something that you need to look at or learn more about. So another interesting thing or thing that probably might want to know is like these are all like problems or these are the things that you might want to know whenever you are trying to build an Elasticsearch cluster. So I don't know again like how many of you use it for building for a real search experience, like whenever you type a name or you type a question, you want to get relevant results. Like suppose if you want to type Paytm, probably you want to get paytm.com. You don't want to get a freecharge.com, right? Or mobiquick.com, right? You just want the relevant results. Suppose if you are typing for something, you want to see related results, not something that is unrelated. So how do you do that? So Elasticsearch comes with a full text search analysis, some sort of a data structures. Whenever you put this data internally, we create something called inverted index. How many of you have seen inverted index? There are APIs to do that or heard of it, because it's pretty common if you have worked with any other search engine. So Solar also uses the same Lucene, so you might have heard there as well. So what basically it does is like whenever you have letters or sentences like this, I'm thinking that you will not be able to see this. So if you have something like winter is coming, ours is the fury, choice is yours, some sort of sentences, then you might want to break this into individual what we do is like we break it into individual terms and we generate a frequency of this, and we also put into where the document is residing. So not just this is just a table, basically a table where we create for you to access whenever you are trying to access. But we also do more operations with something called analyzer. So analyzer is something that really works on your data and filters the data in a specific format, makes it ready for your search queries. So there are several types of analyzers. There are analyzers for English. There are 44 languages that we support. So why I say languages, particularly English is a language, right? Where people used to communicate. Then similarly you could use Tamil, or you could use Bengali, or you could use Hindi. So each of these languages carry a certain semantic meaning, right? So what basically happens is like in this analyzer process, the data would be tokenized and the data would be analyzed and the data would be like made into a certain format. Suppose if you are looking at a word like killer, maybe wrong choice, but yeah. So killer, killing, kill. So 3 has the same stem, right? Kill. So all the remaining extras will be removed, and kill is the only base word that we consider. Similarly, if you have fast and quick, so we only consider quick or fast. We don't consider both, and we remove that term from the data set itself. So these are some of the analyzer plugins that we use internally. So each analyzer comes with a character filter, tokenizer, and token filter. So character filter strips off the data and makes it clean. Tokenizer tokenizes it in a specific format. Token filter does all this filtration that I have told. So whenever you get to this point, that is when you will be able to see all of this beauty or all of this thing. So choosing analyzer is another thing that you need to do. If you are using regular English, then it's completely fine. It does automatically a lot of this. If you are not using, or if you are doing some linguistic analysis or something, then it might be different. So similarly, if you want to do autocomplete, search as you type, right? So that is another analyzer that we provide, like ngram analyzer. So each of these are special. So I would request you to go and look at it. I think we are already out of time, but what I'll do is like I'll just take 2 or 3 minutes just to show the slides. So the same slides are I have done similar sessions at several places. So probably you would be able to get majority of the data, but always anyway I'm there on LinkedIn or Twitter, or I'll also share the link of this presentation so that you could go and look at it. Um, so yeah, so similarly, Elasticsearch has a feature called aggregations. So when I say aggregations, it is something like how many of you have seen, which dumb question maybe, but excuse me. So like Flipkart.com or something like Amazon, right? You have gone to the site. Have you ever looked at the left side? You see something which a lot of filters. So it is called faceting in search or aggregations in Elasticsearch. So whenever you search for a certain set of data set, you would be able to do this aggregations on top of that particular thing. So it will generate all the keywords. So for example, if I have to if I ask for something called smartphone, then it does a bucket aggregation and bucketize the data into iPhone, Samsung, Apple, Samsung, LG, some sort of thing. And if I want to see what is the max and min for the same query that I am asking, then it does use of metric aggregation to generate this maximum and minimum of this particular thing. So there are several of these aggregations which does specific things. There are interesting things that you could do with aggregations. You could also screw up this entire cluster using aggregations. So it's so powerful, it can take you to any way. So that is another feature that yeah, aggregations is something like group by that if you normally look at, right? It's the same thing. So Elasticsearch also can do the regular structured query, like select star from so and so where this is this. Now that we have a SQL functionality, you would be able to by default do with regular SQL queries. But also we have that sort of a queries where it will be able to do. So there is something specific called non-unstructured queries like match query, specific queries where whenever you ask a query, there will be a score that is generated for the result. That means like the results are ranked according to the score. So which comes first, which comes second, there is a ranking algorithm that we use called BM25. So this is another area to explore, like again we could look at it. So all this data we write specific tutorials, we generate a lot of content on our blog, so you could go and read about it. So term queries are queries which does this structured query. Match query is something that is like unstructured query. So there are several sorts of queries. Like for example, the Uber use case which we saw uses geoquery. Like you take my location and it searches in an envelope and finds out which car is there in real time, and then pair you with the driver. Sends notifications to, you might see connecting with 8 drivers. They're connecting with 2 drivers. They send notifications to all these people. They do a search query and try to fire it to everyone. So that's what they do. So using several of these, you could build a large scale architecture like this. This is everything in Elastic. Like what things you could connect, what are the data points that you could look at it. A lot of these. So whenever people ask me about capacity planning or like about how do I size a cluster, it very much depends on your use case. So it depends, the famous word that we generally use where people don't like whenever we say that, because there are, for each use case what we think is like each use case has its own configuration cluster thing. For example, if your use case is full text search, if your use case is logging a metrics or complex aggregations with a lot of users asking questions on top of the data, it will change. So what I'll do is like I'll end the session with probably for one, I'll take one use case and explain how do you do sizing, or how do you come to a number that how many VMs do you need to run, or how many things, or what is the capability that you need to run. So let us take the use case of logging, it being very popular and several of these people use. I don't know why it's not working. Okay. So suppose if you are having an inflow data of 10 GB and then you have your per month data is like then it becomes 300 GB, then your per year data becomes 3600 GB, right? Some people consider retention, that means they don't retain the data after certain amount of time. They cut the cake or like remove the data from your cluster. But if I will leave it for a toss and then just use replication factor as 1. When I use replication factor as 1, it simply becomes double, right? So the data size becomes double and it becomes 7200 GB of data. And all of these factors along with the type of query and the amount of the throughput that you want, whether you want to see the page in 8 seconds or 3 milliseconds or 5 seconds. So all of this depends on the query and the cluster size. So we will come to a number of nodes based on these factors. So that is how you size your data. From the point of cluster sizing, that's how you do it. So you need to know the CPU, you need to know the how much amount of memory, etc. Right? That's how it basically happens. So this is one basic idea. So for this particular use case, I would definitely go with a 5-node cluster with each node having at least like 1 TB data. I'm talking really more, but it covers for 3 years. It just simply works for 3 years. Even though you add new logging, you add some more parameters into your logging, or you add new data, etc. So this is about how do you size your cluster. I'm really going fast actually. But there are some other recommendations that we also do whenever you are looking at, okay. So whenever you're using Elasticsearch to build a cluster, so one of the important thing is nowadays you have several of these clouds and you have several of clouds offer several of these products, like EC2 has I3, S3 type instances or R4 instances. Each instance will do a specific, some instances are memory optimized, some instances are IO optimized, etc. So forget about all of these things. This is something basic to understand when you are building again Elasticsearch cluster to scale. If you are really comfortable, or if you are okay to, if you want to build more scalable architecture, SSDs are definitely best, but it's really costly. It comes at a really good, cost. Local disk is very important. Don't put it on a SAN or NAS, even though they say that we offer you the best switching protocol, etc. Because there is a reason that I tell don't use a NAS or a SAN sort of storage where your storage is somewhere, your compute is there, you just use it in a remote way. It doesn't work for search engines because you are not building Google. You are building a cluster in your some cloud provider. You would be able to do much better work if your local disk is attached. Then don't prefer one large scale machine like 256 GB RAM, like 500 GB or like like 10 TB, 20 TB hard disk, put everything in one node, run it. It will run, but it is not recommended. So it is always recommended to have a medium to large scale machines rather than having one large scale. Remember, Elastic is elastic because it scales like this. This way, horizontally, it doesn't scale vertically. So that is why it's called Elasticsearch. So another interesting thing or something that you might not note is like the heap space or the JVM itself. So whenever you have, suppose take 128 GB RAM machine, only give 50% of it to Elasticsearch process. So don't give more entire RAM to Elasticsearch because we write data to the disk itself again. So when we want to write data to the disk, then we use operating system APIs. Then how do I start doing swapping, I start doing using virtual memory, I start generating more threads, open a lot of file system handles. It's unnecessary stuff. So what we would recommend generally to do is like give 50%, leave 50% for us to interact with your regular file system. So we write disk to the data to the disk. So that is one other reason. Another reason or the final one is like do not cross 32 GB of heap space. Suppose now I said like 128 GB. So 64 GB is the RAM that you allocate to your Elasticsearch. But in that Elasticsearch is a Java based system. You give only 32 GB max to your heap. This is not a R limitation. JVM itself comes with a problem or comes with a situation like called smart object pointers. So it gets disabled automatically, like your heap is automatically organized in a much better manner when you have the heap limit till 32 GB. If the heap limit crosses, your Java heap limit crosses more than that, that functionality will get disabled automatically by the JVM. They are working to get a fix, but this is one another thing to consider. So there are several things that we could talk, because this is a very large topic and we can take one particular use case and start working on it or do more. We will definitely look at some time, and like we'll definitely do more. But if you are like interested or to know more and know more stuff, uh, so this is a particular URL where you would be able to find details of all those links. I hope it is visible. I made it maximum. So you could go and get more details about the talk, or I'll also put up the link of this particular presentation. So I'll also give on the meetup, I'll give the contact details to do if you have any questions or something. But other than that, that's it. If you have any more questions, I'm happy to take, but we are already completed or like out of time. That's it from my side.
I have a question.
Yeah.
You told again, but why should we not use NAS or SAN type of architecture?
So whenever you use a NAS or SAN kind of architecture, what basically happens is like you do a lot of switching between the network, right? Yeah. So what you basically do is like you do a switching between all this network infrastructure. So it is not really recommended. Your data has to travel the hops between your real compute and your storage. You are not really building such sort of infrastructure, right? So it's better to do that way.
So is it it should be appreciated for big architecture or small?
Just give me a minute. People, please share your feedback in Meetup, or you can even write in sticky, and you can post it in the whiteboard that is placed next to the table. And this is one of the biggest crowd that ever been to GeekNight, and hope it continues for the next weeks as well. Thank you so much, and thank you Aravind for that. You can have your dinner in cafeteria and the dog.
It's Java product. So Java is going to be like doesn't matter, right? You have open JDK, right? Elasticsearch and Java is not related. They're based on Java, but Java is still based. So Oracle JVM is licensed, not Elastic. The Java is not licensed. If they do that, they will license. Okay? So there is something called open JDK. Everyone is using open JDK. Not many people. Everyone. Even today, if you use Oracle JVM, they are not releasing anything, but you won't get updates after 6 months. Big bump of your version. Earlier they used to support 3 years, like LTS. Now they are in a different release cycle. They want to upgrade. So Java is a very critical system, right? Your applications are running on Java. You will not be able to upgrade so fast. Not many of them. I didn't get your exact question.